In the previous section, we talked about how we could represent a function with a graph. But it's important not to think that all graphs give rise to functions. There are particular rules that need to be applied. So if we have this general, we have the input and output, and if I were to draw some arbitrary graph, or now maybe looks like this, then I can demonstrate that this cannot be the graph of a function. The biggest problem is, let's take some arbitrary point A, say maybe here, and I look at its output. Well, one way to go, I go straight up and come here and say that's y1. But I could also come down here, getting another output, y2. So if this red curve or red graph were the graph of a function, then I would have that the point A, y1 is in the function set, and the point A, y2 is also in F. But that can't happen because I have one input and more than one output, violating rule 1 of our definition we had above. We can remind ourselves, we can look at it. Real function is a set. There can be exactly one real number B in which this ordered pair is a member. But in this example, we violated that. And in general, we have this rule. If any vertical line is drawn and it crosses the graph in more than one place, then the graph does not represent a function. And that can be called the vertical line test. Now that we know how to visualize graphs, let's talk about some other features of a graph. We have what's called the domain. The domain is the input of the function. So the formal definition, we have that the domain of the function is the set of real numbers x, so that f of x is defined. Now, once we know what the domain is, what can go into our function, the next question is, what is the range? What is the output? And so formally, the range of f is the set of values f of x, where x is in the domain of f. So a few examples of functions for which you should know the domain and range. Let's kind of just make a table of some of those. So we can list off, let's say we'll look at the function. Oops. F of x. We can look at its domain. And its range. So some examples, say, would be x squared. X squared, oftentimes when you want to think about the domain of a function, you want to ask yourself, where is it undefined? I know it's backwards, but when you want to know where a function is defined, best way to start is ask yourself, where is it not defined? Where is it undefined? And x squared, you can square every single number in the universe. So the domain is going to be all real numbers. Now, when talking about range, you want to ask yourself, what is the output? Well, we know something about x squared. If we take a number and square it, it will always be positive. So we can't have negative numbers in the range. And in fact, we would have all numbers including 0, since 0 squared is 0. And then we would get to every single other positive real number. So the range would be from 0 to infinity, including 0. Another example would say 1 over x. Now again, when we're talking about the domain, you want to ask yourself, what can't you do? And we can never divide by 0. So the domain is going to be all real numbers except for 0. So I would write it like this, negative infinity to 0. We don't include it. And then we have a union 0 to infinity. And notice we have soft brackets because we can't include 0. We also can't include infinity because infinity is not a real number. Now the range, again, think about numbers you can put in here. If I put very large numbers in for x, this ratio will be very small. But if I put very small, close to 0 numbers, this ratio will be very big. So I can get all real numbers, except of course 0. There's no way I could divide and get 0. So my range happens to be the same as my domain. It would be negative infinity to 0 union 0 to infinity. Let's do a couple more examples. I think oftentimes students have a hard time figuring out what a domain is and what a range is, because there's not always an algebraic way to do it. You have to analyze it. You have to think about the function itself. So let's look at, say, I don't know, maybe 3t plus t squared. Now, as far as domains go, there is nothing that I couldn't put into this function. So the domain will be all reals. Now, the range will take a little bit more work. I've got to ask myself, okay, what can come out of this? Now, it's probably easiest to sit down and graph this function and try to find out where the vertex is. We'll get better at that, but on your own, see if you can work it out. Use your algebra skills. Right now, I'm just going to tell you what the answer is. So my suggestion to you is review your algebra ideas about quadratics, maybe graph it, use a graphing calculator. You can do any of those tools. We're going to develop more tools in calculus to help us find out where the lowest spot here is. But pause right now and take a minute to try to work this out. Okay, assuming that you have paused, and you would find out that the lowest this function can get is 9/4, negative 9 over 4, and it can go all the way up to infinity. Again, we'll develop some tools in calculus to figure this out, but you actually had the ability already. So get a function like this. Let's do x squared minus 2. So now when I'm looking at the domain, I want to make sure that this is always positive, because I cannot take the square root of a negative number. If I take a square root of a negative number, I end up with an imaginary number. So I want the radicand, the algebra expression inside the radical, to always be positive. So I need x squared minus 2 to always be positive. Again, we'll spend some time later this semester reviewing how to do that, but I would like you to pause, work your algebra, and find out exactly when x squared minus 2 is positive. Okay, welcome back. Hopefully you worked out and you would find that this is always positive. Well, we know it's going to be 0 at root 2 and negative root 2. And so those are kind of our key anchor places, and a little bit of work you should be able to see that this will be positive. So the domain goes from negative infinity to negative root 2. And we include it, because negative root 2, if I square it, I get 2, I subtract 2, I get 0, and the square root of 0 is fine. I can do that. And it'll be union root 2 to positive infinity. Now regarding the range, what the output is going to be, then we're in a situation where we know what is the output of the root function. Well, as we already talked about, the root function always returns a positive value. So we know, and when we're at positive or negative root 2, the output will be exactly 0. So we know we're going to get 0, and the square root function behaves very nicely. It grows forever, and so it'll get as large as we possibly want. So our range will be 0 to infinity. So here's just a few examples of functions for which we have the domain and range.